Okay, in this video we are going to do math methods and numbers. So this is the last of the basics of JavaScript before we look at JavaScript in web pages. And again, the reason that we're doing all this is because getting rid of the web page part makes it easier to make sure we know what we're doing with all the building blocks. So a couple examples that we have in mind: distance formula, generate coin flips, or die roll. But the real point is to have some examples for each of these things listed here. Let's get into JavaScript. So first of all, let's make a directory JavaScript math. Let's see, we already have a directory for string and math. Yes, we'll go in there. The first thing on our list is a note about scientific notation in hexadecimal. Let's just make a, let's see, first we copy from empty, and we'll make a file that will just print out the number and the number plus 1, just as an example. Alright, so we're going to call this printnum.js, and printnum, and this should be some number. And the idea here is that if they run it like node printnum.js, 1, 2, 3, 4, then it should print 1, 2, 3, 4, and why don't we say plus 1 equals 1, 2, 3, 4, 5. Sorry, 1, 2, 3, 5. Okay, and we could also give numbers like 3.14 or scientific notation. Let's say instead of 1, 2, 3, 4, we could do 1.234 times 10 to the third power. So the third power would move the decimal point over 1, 2, 3. And we could also give numbers in hexadecimal. 0xf should be, instead of the value of f as a hexadecimal number is 15. Okay, so we can try each of those out and see. First of all, let's get the number. This would be in process.argv bracket 2, and just as a check, what is the data type of this variable as I typed it right now? Pause it. Alright, and the data type right now is string. So this is a string. If we don't do anything, it's just a string. Let's just print it like this first of all. Console.log num. Okay. So I'll run it here, node print num, and if I run it like that, I should get the error message saying I need to give a number. So let's give 3.14. Okay, and what if I do num plus 1? There are 3 possibilities. It could give me an error. It could add 1, so print 4.14, or it could put the 1 on the end because this is a string. Let's just see so we know. Okay, and so there it put the 1 on the end. This is a string, so then it's converting this to a string. If we want to have it view num as a number, then we need to convert it. So I can say num equals parse float num. So parse float is on our list here. Parse float that takes a string and converts it to a floating point number. So note, let's go to our data types here. So integers in programming typically have a maximum and minimum possible value depending on how much memory is allocated. In C or C++, typical integers go from negative 2 to the 31 up to 2 to the 31 power minus 1, roughly negative 2 billion to 2 billion. Okay, this isn't C that we're doing right now, but that's an example. We'll say what happens with JavaScript in just a second. So that is an integer, a floating point number. This is for numbers that have some decimal part or after the decimal point. And then we'll typically have a max and min and number of significant digits. Okay, in JavaScript, all numbers are 64-bit floating point. So the 64 bits goes into saying how many digits of precision and how large and small the numbers are. So there is no such thing as an integer. But let's just give a test of the precision here. So let's put 3.14159, 26535, 26433. That might be enough. Let's make this a little wider. 26535, 26433. I don't remember the rest, so we'll just go 1, 2, 3, 4, 5. That 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Alright, and see what we get. So we see here that we have 26433, there's 26433, and then all of the rest of us is actually not retained. So the number of digits of precisions we have is just this amount right here. Okay, so that is that. Let's see what happens if we do 1.234 E3, so that's supposed to be the same as the number 1234. There it is. We're printing the number plus 1. Why don't we print both? Like we said we would. Okay, so this would be put this in parentheses to make sure it views this as it'll do the arithmetic for us, and then we'll do equals, and then we'll do right, num plus 1. Okay, I actually said I would do this the other way, so we'll do num plus 1 equals this. So again, how is this going to be interpreted? Everything between the quotes here is a string constant that's just printed to the screen like that, and then it's going to evaluate the things on either side, and this is a number. It'll convert it to a string so it can be put together with that one. And then this one here, if I put the without the parenthesis, it may do something different. With the parenthesis, you always look inside the parenthesis first. So it'll do the arithmetic, and then it'll convert it to a string. Let's just see. Okay. Let's look at the 3.14 example. It's kind of interesting. 3.14 shows up fine, but then on the other side, it shows 4.14 with a bunch of zeros and then a 1, and maybe you know why this is, maybe you don't. So the reason is that in the computer the numbers are stored in binary as bits. These numbers here, we're writing them out as decimal in base 10, and 4.14 has 3 digits, right? So 4.14, the number, has 3 digits in base 10. In binary, what's happening is there's some repeating digit or something like that happening. That when you convert between bases, what's easy to represent in one base with just 3 digits may turn into something that has a repeating digit in another. An easy example of this would be the fraction 1/3. Okay, so I'll just put this in the file here. Interesting note. So 1/3, okay, as a decimal is 0.3 repeating, okay, in decimal, but in base 3, this number would be 0.1. We haven't done numbers, but in base 10, if you wrote this, this would be 1/10. So in base 3, this is 1/3. So in base 3, you can write this with 1 digit. In base 10, it's a repeating decimal. And so because of this, when we type numbers in base 10, it may not be representable in binary in base 2. So we can have things like this happening. Alright, let's see. So we tried out the scientific notation. Let's try out the hexadecimal. That is so it did not read the hexadecimal. Let's try putting here num equals 0xf. Okay, so that looks like we let's pause for a second. Right, so we can do that in the code, but not apparently the parse float. Right, parse float wouldn't do that. Let's try it with parse int, because there's both options. There's parse int. Still doesn't like it. All right. Wait. Let's do this. There it is. Okay. So if we know it's going to be an integer, because this is an integer value, it's not going to come up with any decimal points because there's no way for us to put it in there like that. All right. So either we can do the scientific notation with decimal points, or we could have the 0xf. We could have a test here. So if we want to say if the string here has a decimal point or an e, then we should do parse float. Otherwise, we should do parse int. So how do we find if there's a e in there? So this is one way. If this gives us something that's at least 0, so this is supposed to tell us the first position where there's an e, or num.index of decimal point is greater than or equal to 0, or I believe you can use a capital E. So any of those would seem to indicate that we're talking about a number with a decimal point. So there I just ran the 3.14. Let's run this one again. Okay, so both of those work out all right. All right, there we have our different types of numbers, and our issue with limited precision. So there's only so much precision that we get, and it depends on this 64-bit issue. And then we also have that not all things that have a small number of digits in base 10 will come out the same way when we print them again because of converting between bases. Alright, so that is just dealing with just plain numbers. Now let's take a look at the other list of functions that are available to us. Okay, so we have parseInt, parseFloat. These numbers, infinity and negative infinity, we should do something there too. Let's save this and call it inf, or we'll call it limits, num limits. Okay, so what I'm thinking of here is so let's say we want to get something that tests the limits of how big numbers can get. So that we'll see this infinity, negative infinity. Why don't we look at here well, we've already seen, let's see, we'll do no arguments. Alright, so I'm just going to print out some things here and we'll see what we get. So I'll say var x, let's see, I'll do console.log 1 divided by 0. Okay, so those are two numbers. It's going to do the division. What do you think will happen? Either it's going to give us an error or print something. You're not supposed to divide by 0. Okay, so that said infinity. 1 divided by 0 is infinity. Alright, let's do negative 1 divided by 0. Negative infinity. The way that we would usually get, so I'll say console.log, let's see, why don't we put it in here, 1 divided by 0 equals plus, and then we'll have the value. And we need to put the value in parentheses because we want it to actually evaluate it before converting anything to a string there. Negative 1 divided by 0 equals. Okay, so that just prints a little bit nicer, and let's just see. Okay, so there we still see the infinity. Let's make this 2 windows. Okay, so but what if this was, instead of a divide by 0, what if it was a plus 1? Plus 1. So what would you expect to see? This 1 divided by 0 equals, I'll still see the same, but instead of infinity, it's going to be 2. It's 11. And so that's because it's doing the plus 1 first, which converts this to a string and adds it on, and then it does the next plus 1. So that's why I've been using the parenthesis. So why did this print correctly? I'm going to run that, and it does do the division first. The answer is order of operations. It looks at this expression and it says division happens before addition. That's from math. Just to be sure here, because we're mixing strings and numbers, I put the parentheses. Okay, so there's those. Another way that we might come across infinity is if our numbers got too big. So let's say var total equals 1, and we'll say var I equals 0, I less than, let's do 30 and see what happens, I plus plus, and we'll do total times equals 10. So we're going to multiply 10 onto total and then print. Total equals plus total. So eventually the number should get too big and it will print infinity. Let's see our error. Line 11, console.log. Okay, so if we look over here, we should see increasing powers of 10. So we do 10, 100, 1000, and then we get 10 to the 21st, 22nd, 23rd, 24th, 25th, 26th. There's some issue with binary versus decimal or something, number of digits of precision here. Let's make this go up faster, so let's multiply it by 1 million each time. Okay, so we should be increasing by 6 on the exponent each time. We start off being 1 million. 1 million times 1 million is 1 trillion, and then increasing, so every time it multiplies by a million. Let's go even more. Let's multiply by 10 to the 20th each time. Okay, so there we did get up to the infinity, and the last number we had here was 10 to the 300th. So the max number that we can get to is somewhere just around 10 to the 300th. If we want to make this printout smaller, now we could probably do multiply on 10 to the 150th. Okay, so there's infinity. And we could test here instead of, let's see, if total equal infinity, console.log overflow or max number reached. Okay. The other value that was in there, let's get rid of this to go away. Alright. What if we print, let's say we want to print something like 1 plus hello. Okay, so what do you think that's going to print? Or let's do let's say we want to print, because that'll just put a 1 onto hello. Let's say we want to do parse int hello. Alright, so we want to do the integer, convert this to integer, doesn't really make any sense. That's where we should see this NaN. I need to save. So there's the NaN. And those are the values, and we could test against that as well. So var x equals parse int hello. And we could say here, just print x, that should print NaN, same. And we could also test against it. If x equals NaN, that's a special value, and it shows up different color there in Emacs. I don't know. So that did not print. So, alright, we'll just leave it at that. Let's move on to, that's everything that we were supposed to know about numbers. We have parse float, parse int. Other methods to string will convert a number explicitly to a string. So if we wanted to do something like let's say what do we have so far? Let's see, let's say we want to do print num, and we'll call this digits. And say we want to do something like we want to get num and maybe d, and we want to print the dth digit or something. Okay, there's a bunch of different ways we could do this. First we need to get the number. Let's just say we're going to assume that this is an integer. Okay, so that's an integer, and one way that we could get, let's say we want to print the dth digit of num times d. Alright, so we're going to multiply num by d, and then we're going to get the dth digit or something. Alright, I'm just making something up so that there's a reason to convert this to a string. So we could say num equals num times, now if we're going to get two arguments here, then we need 4 there. And the next one would be var d equals parse int well, let's do it instead of num times d, we'll do, well, sure, num times d is fine. Alright, so there's the result. We'll call it result maybe. Okay, now that's some integer, some number. If we want to get the dth digit, we could do that as a number, but I'll do it to string, so to string. Now s is a number, and I could console.log s bracket d. Okay, so since s is a string, let's just run this and see. Okay, so we get our message telling us to give more. So let's say we're going to do 6 and 2. 6 times 2 is 12. We'll have to do, let's see, 52 and 2. Alright, so 52 times 2 is 104. Get an error. Let's see. Parse int. Okay, so what we get here is 52 times 2 is 104, and then as a string, the 1 is the 0 position, 0 is in the 1 position, and 4 is in the 2 position. That's not a real super exciting example, but there we are converting a number into a string in case we want to use it as a string. Alright, now we can get into some math functions and do a slightly more interesting example. So all the usual things you would have on your scientific calculator are inside of the math, capital math. So there's pi, the constant, rounding, power, square root, absolute value. Ceiling means rounding up. Floor means rounding down. sine, cosine, min, max, and random. Let's take a look at random first. So we'll do coin, let's do, so we'll take this and save it as coins.js. So now the usage will be coins and how many. So what I'm thinking we do here is they say coins.js and 5, and we flip 5 coins. Heads, tails, tails, heads, heads, maybe. Okay, so first we're going to get that how many. I'm going to do parse int because that should be an integer, v bracket 2. Okay, so now what I'd like to do is flip some coins, and to start off with, let's just flip one coin. So what we have available to us is we can do parse math.random, and to start off with, let's just print that to see what that gives. It should be a value between 0 and 1. That's what. So if I run this multiple times, it should give different values between 0 and 1, and we'd have to look it up. Is there ever the chance that it actually is 0 or 1? Alright, so now if I want this to be, instead of between 0 and 1, maybe I'm thinking heads versus tails is a 0 or 1. So one way to make this into something that's either 0 or 1 would be to say value equals value times 2. Okay, so now this is going to be between 0 and 2, right? So then I can say value equals, so it's between 0 and 2, and roughly 50% of the time it'll be 0 point something, and the other 50% of the time it'll be 1 point something. So if I just say value equals value dot floor, then that should be between 0, it should be either 0 or 1. I'm cutting off the after the decimal point. Let's see. See what it says. Right, it should be math.floor. So math is the collection of functions. Right. So if I want to save that into value, so math.floor is what I want, and let's save that back into value. So the value variable should be, right. So math.floor, you give it a number, it'll cut off the stuff after the decimal point. We should see this come up 0 or 1 roughly 50% of the time. Okay, so this part here was the part that flips the coin, basically. So now I'll say if value equals 0, then it's a head. Just put that there for now. Otherwise, it's a tail. Alright, I want to put this into a loop, because I have this how many. So when you want to do something a certain number of times, this is something you should just remember. I equals 0, I less than how many, I plus plus, and then inside of curly braces you have the thing you want to do a certain number of times. So I'm going to take out this console.log for now. Okay, so this would flip a certain number of coins. Why don't I go ahead and I'll print it. Let's say that 0 is heads and 1 is tails. So there I should see different values come out each time, and that's 5 times. Okay, if I want to make this shorter to print so it doesn't take up five lines there, I'll save this into the results as a string, and instead of printing it, I'll add that to the results. And print the results at the end. Save the file. There it is. Alright, so now we could do, if it's not so much, we could do 20 of these. And you could count by hand, but let's count how many are heads and how many are tails. Let's say heads equals 0, tails equals 0. And if it's a 0 and we print an H, then we should count tails plus plus. And if it's a, sorry, that should be heads plus plus. And otherwise we should have a tails plus plus. And we should print it. We'll just say number tails equals plus tails plus heads equals plus heads. So the larger we have for this value here, the closer this should get to 50%. So we'll say console.log percent heads equals, and now we'll do heads divided by the total, which was how many. And if I want to have a really lot of trials here, and I probably don't, I would like to print this count for say 1,000 or 10,000, but I don't want to see all of these printed. So I'm going to put here only if how many is less than say 50 will I actually print that part. So let's try, let's just, okay, we got 45% there. So we should, if I want to make it a real percent, times 100. And if we want to print the percent, there's that, just to make it nice. Okay, so that's not so great. Let's use one of our other functions here. So there is toFixed. That'll only print a certain number of digits. Let's just print 1. Okay, so that's never going to print more than 1 after the decimal place, which would be nice. Okay, so if I do higher values of this number of coins, it should get closer to 50%. There's math for why that's true, but if it's a good random, so if what they're giving us is good random numbers, let's just do, this is 10,000, so I run that, and the furthest away that has been was 0.6 away. If I just keep going more, eventually it'll start to take a little bit of time. 1 million. So that's just 0.1% away from 50%. Which is kind of cool. Alright, so we got a chance to use toFixed and floor and random. Maybe we should do square root as another example. Why don't we do, let's see, we'll take the coins as a starting point and call this test we'll call it test Pythagoras.js. Test pith. So I'm going to give it A, B, and C. Should say if A times A plus B times B equals C times C. A squared plus B squared equals C squared. That's for right triangles. And I'm expecting 3 extra arguments, so I should have at least 5. 1, 2, 3, 4, 5 now. And what I'm thinking is test pith.js, if they say 3, 4, 5, then maybe it would print Pythagorean triple. So that's what it's called when they are a right triangle, because if you do it 3 squared is 9, 4 squared is 16, 5 squared is 25, and 9 plus 16 is 25, and if you put those together in a triangle, it will be a right triangle. But if I say node test pith.js 3, 4, 6, it should say not, or whatever we wanted to say. Okay, so I could have a test here. First we need to get these variables. A equals, B equals, and we can use comma here, and C equals. Okay, so this is going to be parse int process.argv bracket 2 parse int process.argv bracket 3 parse int process.argv bracket 4. Okay, let's put our test in. A times A plus B times B equals C times C. Then I would print and maybe I'll put a little space there just to offset it, and otherwise console.log not. Let's test it out. That says that that is. That's not. If you happen to know any others, let's see, 5, 12, 13 is as well. Those are the ones you would remember, those two, 3, 4, 5, and 5, 12, 13. Okay, so this didn't require any math stuff at all. We could have done this other ways, and depending on what the numbers are, it would work out. So we could have done, if we want to do a squared, like the second power, then we could do math.pow for power, and a comma 2. So there's a function called pow. Let's see if this runs. Okay, it still says it's a Pythagorean triple, which is nice. Math.pow b2 and math.pow c2. So if we had some equation using some other powers, we could use that method, and it should still say 3, 4, 6 is not Okay, and then for the other, so this is a squared plus b squared equals c squared. Instead of doing c squared here, we could do math dot square root, and then that would get rid of this second power. And depending on if there's any issues with the numbers, that still works for these couple of examples. This version here actually has less chance of numerical errors with the numbers we're using, but this is just another example of POW and square root. And this also gets us, yeah, we'll leave it at that. Sine, cosine, min, max. Let's just go ahead and take a look at the link here. So if these functions are needed, so there's the constant pi if you don't want to type. So round is rounding either up or down. If we always want to round up, we have the ceiling function. If we always want to round down, we have the floor function, depending on what we want to do, and round rounds up or down, depending on what's closer. POW we saw, square root we saw, absolute value, ceiling, floor, sine, the trigonometry, sine and cosine, or geometry, depending on where you see those. And min and max, okay, so we get a whole list of numbers, which is, we could do that. Alright. And some other constants. I think we're probably, that'll be it for our math. So I'm allowed to ask you about to use anything that would need these, and there you have the link, and we have a few simple examples. The end.